Alright, so. Yesterday. How do you think class is going? Went, all those things?
I think it went well. We're definitely getting to a point where we're more comfortable discussing things. Whereas, sometimes you have that battle with kids who just want to do the work. We're getting to the point where no, we're gonna do these two, and then if it takes us 15 to 20 minutes to talk about these, we're gonna allow that space. And I feel like it's 70-30, 70% of the kids are listening and are looking for wait, I actually don't agree with what you said. And then for the kids who don't know what's happening, who probably need to be in a small group or something, it's kind of just idle time for them. So.
No, I mean, what I thought was really, I was looking for your engaging in class conversation, the full responses again.
Mm-hmm.
And, I mean, the engaging in class discussion, you had so many kids participating in the hand motions. You had, D'Angelo being able to answer a question very, succinctly on point. Both Jamila and Kaylin shared their answers, and they were full sentence, thought out responses for the two of them. That's, big growth from last year. I mean, it's they're repeating, it's a challenge to be a repeater, and they're giving these quality, not choppy, explaining my thoughts. But then you have the whole equation gets set up. You had, I was sitting with Micah and her friend there, and Micah explained the difference between zero and undefined perfectly to her classmates. She was confused, which one's zero, which one's undefined. She was lost, and she's well, think about this. If it's zero or something, your calculator is going to be able to say it's zero. So if it's a change in y, not a change in x, that's zero, or changing. She did absolutely perfectly. Girls, I get it now. And just got the rest of the questions right.
Mm-hmm.
So you have things like that going on with students who are being helpful and getting together. You had a student in the back really explain why the y-intercept could be anything pretty well during the discussion. I mean, you called on a lot of people, and then even in class, I think Tia sat in that back corner with a group of what appears to be their work level, the low students, and they were all willing to share their answers and try to be a part of the conversation.
Yeah, she really tries to help out.
And so
as much as she can.
No, and I know that it's not her jam to be in there doing math, but she's definitely back there, and that group then has that extra support, and they feel like they can, when it comes back to whole group, they're sharing out. So I mean, you have, this is, and when I'm sitting here thinking, I'm wow, we have this really academically low group of students who are trying academically rigorous problems and trying to explain them in a meaningful way, and it was really cool to see. And then I think it works so well because you're using, the three of you are actually working quite well together. I know it's still a lot of Ms. Thomas is the head of this classroom, and then there's two other people here, but the way that Tia is being deployed as helping the low table really stay on point and get the questions answered, and then kind of being an extra floater at any given time. The three of you are engaging half the class, and the other half of the class you can pretty much let go, as you have the students who are playing the role of extra.
Yeah.
Ms. Corlick or Ms. Thomas. Things looked really good there. The only time that you had disruptions or off task things, I think it was just because of being challenged.
Mm-hmm.
And that's what I as far as next action steps for that class, and just in general with your co-talk classes, is how do we actually chunk up the challenges so kids don't feel as lost for as long? Because that's what those questions are inherently challenging, because they don't have points to work with. They have to understand. It's a purely conceptual understanding of slope at that point. And so that's when you saw kids get confused and try to explain those kind of things.
Mm-hmm.
So in terms of how I would want to go about this in the future, I'd want to, let's think about yesterday. You had the 6 questions on the front that I was there for. You did 1 and 2, and then came back and you explained them, kind of sit back and forth, right? Then you just said, do 3 to 6. And in doing 3 to 6, the 3 of you bounced around and tried to help people out with them, but you spent probably 7 to 8 minutes on 3 to 6 independently, and then try to explain all of them at once.
Yeah. Okay.
If that makes sense. So you think about what it looked like for students was, this is really hard. Trying to do it, and then having to get help, and then get all this help, and then coming back, and it's okay, now let's explain each one of these individually whole group, and so you end up with this chunk of 20 minutes that was like front-loaded work, back-loaded explanation, and had like I think like the very simple changes like do number 3, and then let's talk number 3, then do number 4. Like, 'cause I think with that class, like they want to learn the challenges. I think that's what's really cool about it. Like you have a group of kids who haven't traditionally wanted the challenges, but now they want to learn this new thing and be like ready for it, and then it's really cool. But I think what you have to do then is be smart about how much alone time they're getting, like for lack of a better term, because they need that. Like, I'm gonna try this, come back, fix it, and that way I can try number 4 now that I have this new knowledge that I can go with and go like that.
I think I struggle with defaulting to. So I really want to work on talking less, but that doesn't mean like that they're talking more and not on task. So it's kind of like I just feel like my release needs to be more gradual, as opposed to like you got 1 and 2, dive in.
Yeah, no, and that's my natural inclination too, is like to do the dive in. Like I've been running into trouble this year. I walk around like,
crap, now I have to wait for the 7 minutes to be up when I could have just tried to work on this 1.
Yeah, and so I think like the way to avoid that, like you're going to talk less because there's going to be like, okay, we're doing number 3. Someone's going to explain number 3. And they explain it. Okay, yeah. And like, now, do you have questions on 3? Oh, I understand. And like that way, it's just like boom, boom, boom. You're still doing the same amount of work. Like it's still the 7 minutes, but you're doing it as like a minute and a half. And then explain. Then a minute and a half, then explain. So that way there's never a chance for a student who's struggling to get super lost. There's always an explanation. And then as it goes, you should be just like kind of picking up more kids to the point where, okay, we get to 70, now let's try 2. And I think like that chunking of what effectively ends up being like a lot of guided practice for a challenging lesson with lower students is like, okay, I've explained the concept. We're going to just chunk these back and forth until I feel like 90% of you could do this pretty independently.
Yeah.
And so like that's the one place I'd like to see that lesson in like future challenging lessons change, because you have the investment, the kids want to know. It's just breaking it up in a way that they can never get too far away, and like kind of keeping them in that
like digestible.
Yeah.
I think I also underestimated how hard that was for them. So I was like, today's gonna be pretty easy. We're just estimating slope. Is it going up or down? Is it close to 0 between negative? Like, to me, that as opposed to like, I don't know, that and writing equations of the lines comes super easy to me. Like I can understand where kids got confused with vectors and transformations, but estimating slope is just like, is it steep, is it not steep? Like, and I truly underestimated like, oh, this is really hard for y'all. Like, just put some tick marks there. I didn't realize how difficult that was for them
and
when you just took away the lines on the grid. I was like,
when you take away the lines on the grid, it becomes, and like this is what happens. Like the difference between lines on the grid and no lines on the grid is the conceptual understanding of slope. Like, is this rising more than it runs? Is the change of y bigger than the change of x? And like that's a pretty big gap to try to figure out, because we have this situation where you're going from, oh, I can just count. I can make a triangle and count, to there's no way for me to make a triangle. Like I have to understand that I'm going up by a smaller amount, and that's what makes fractions. And so
we're just not being explicitly told like, this is the y-intercept. I'm like, no, you can just make it up. They're like, wait, what?
Yeah.
What are you saying? Or like, look about where it crosses.
Like it's more about positive and negative. It's making broad generalizations from a very specific concept, which is a challenging skill.
Yeah.
And so I think like and when I first started teaching this as a lesson years ago, I thought it's like it's gonna be easy. It's like there's no calculation. You just have to understand that like it's flat,
there's no
or it's
right
tall.
answer.
It's either,
and I think that the lack of
or it's flat, but it's
the lack of requirements is what's scaring them. Like they're like, well, if you want me to do a negative half slope, like what's the y-intercept? Oh, you can choose it. Wait. Just tell me what it is.
But I want to know
there's no
exactly.
Right. Yeah.
So it's like breaking them of that idea of exactly right. This is the perfect answer.
Which is not how math is typically. It's like the answer is A.
But yeah, so that's what I would like to see you doing. I mean, going forward is bringing those challenges up. So like, in terms of today, so like a real quick thing today, do you have today's like readily available on your
Yep.
Can you see what they're doing with the scratches for today?
computer.
So your computer's
Oh,
on
yes, we are in today. Gotcha. Okay, unbox. What we doing? Yeah, parallel and perpendicular stuff. Which is another, this is super easy. Like in my head, I'm like, oh, come on. Sorry, that's yesterday's. Oh yeah, I really have to explaining that. Like you saw that picture I sent you. I was like, why did I know this?
So like, these are like calculations that they've done before. Ooh. A lot of reading in this one.
Mm-hmm.
So I think like when you're doing this, I would chunk it by the parts almost.
Okay,
Let's do
okay.
Part one. Let's do part one. You're just calculating slope and then going over what it is, because like part one's relatively, that's calculation.
Mm-hmm. We do part one, or I do like parallel, perpendicular.
And
They
let them
finish.
try part one,
Okay.
yeah. Or maybe like you do number one where you're like, let's find the slope of line P. Okay, we now know line P. What do we know about line M? It's parallel. Go back to your notes. What does parallel mean?
Mm-hmm.
And then write that slope. And then that way you do it for one, and then you can do it for two, three, four. Just makes it
Gotcha.
tell them to read carefully. I think they're all some perpendicular. And then when you get here, it's like, we gotta draw a line over here. You gotta figure out what the slope is. I mean, I think you just chunk it up by parts, because this is where they start getting conceptual. Like you have to understand the connection of those things and the challenges for those two.
Mm-hmm.
Like I think you're really looking to get through up to 11 today with that group.
Okay.
Like, man, in your head, you should be going in with the idea that like everyone's getting through for 11 today.
Oh shit. Okay. I'm super slow. But yeah, I need to. Now that's, I've told Jackie that I was like, you're really good at pacing. I have no idea how you're getting through all these problems. But now that I have like a, you should get to 11.
Yeah,
that'll help
think
me
about what
with
your notes are.
attention.
Like, write down everything. Feel like smart fans. These are relatively quick, like 2, 2, 1 half, undefined, 0, and then the perpendicular, like those guys are same. Show the different slopes of oblique. It's like, oh, it's just slightly. Show the ones that are slightly different, like -3/4 and 3/4 are oblique because they're not reciprocals.
Mm-hmm.
They're like calculating slope they've done, so it should be pretty quick to calculate. Then it's just actually doing the parallel and perpendicular.
Mm-hmm.
It's like this could be a relatively quick portion of class.
Yeah,
Maybe
that's
if you have
true.
a group that's like have a group that's struggling with this, like that's where you do the separation, or have a group just kind of hang back.
Mm-hmm.
And then part two, it's like you're doing the same thing we've been doing in terms of slope. Now you have points again, so you make a triangle.
Yeah.
And calculate it's just asking you to draw a line that has that particular y-intercept and has that slope, so that you can see what they look like. And that way you'll be able to see what parallel looks like and see what perpendicular looks like on the graph. They do it right. Is that what perpendicular? Yeah, these are going to be the ones where you're going to have some time where you're going to be like, do number 8, see what happens. Talk about it, then do number 9, that type of thing. So I would do these part 3s separately because they're the ones that are going to be the hardest for them to wrap their heads around.
Got it. So 8, come back together. 9, come back together. Okay.
That way you're not saying do 8, 9, 10, 11, and if you don't know how to do 8, you don't know how to do 8. So like, that way you don't get lost.
That's true.
So that's how you avoid the lost problem. there.
Yep.
The other one, so the first one, and the way that this is structured, part 1 is like straightforward, calculate, go. Part 2 is calculate on a graph and draw. Like it's things that you've done before, just with one more step. This is where you have to like do 2 separate calculations and then think about the relationship, and like it's not you're not creating, you're actually working backwards, which is sometimes harder.
They even struggle with the phrasing of this. Like they know these, and then on OER will be like, what is the relationship between the 2 lines that are they're like straight?
The lines are both straight.
They're linear, pair. I'm like,
It's true. What you're saying is not wrong.
they go on forever. That's not their relationship.
I'll send these to you. There is a chance that I come in 6th period today.
Okay.
That's a chance.
6th. We move so quick in 6th period.